This is Ham College, episode 69 for September 30th, 2020. Ham College is brought to you by ICOM and the new revolutionary IC705 with optional multifunction backpack. And by hamstudy.org, a great way to study for your next amateur license exam. Good evening and welcome to another episode of Ham College. I'm Professor Thomas.
And I'm Dean Martin.
And we've got an interesting show lined up tonight. I guess the title is going to be Hams in Space.
In space!
So we're going to be talking about amateur radio in space. Got a number of questions there, and I'm going to tell you, you probably want to study these ahead of your exam.
Yeah.
What did we talk
now
about?
You tell me.
Yeah. What did we talk about last month?
I believe last month we talked about VE, the VE program.
Well, I believe you're
being
right.
VE and so forth. Huh?
I believe you're right. The Volunteer Examiner Program.
Yeah.
Well, anytime we're doing a live stream, we've got something else going on at the same time.
Usually many things going on at the same time, but I think you're talking about the chat.
Yeah.
So you can join us in the AmateurLogic.TV chat room at the URL you see on the bottom of your screen. And it's really a lot of fun. There's a good group of people in there, and kind of adds a lot to watching the live stream. So if you're watching a live stream and you're not in the chat room, you're missing half the fun.
And if you're listening to the live stream, well, that link is AmateurLogic.TV/chat. You've got some splaining to do tonight.
I do have some splaining. It just so happens to be on topic for tonight also. An amateur radio satellite is an artificial satellite built and used by ham radio operators. They form the amateur satellite service. They're there for us to use for communications between hams. You probably heard the term OSCAR in reference to amateur satellites. OSCAR is an acronym for Orbiting Satellite Carrying Amateur Radio. That's pretty creative. This is a designation assigned by AMSAT, an organization that promotes development and launch of amateur satellites. Because of this, amateur satellites are often called OSCARs. These satellites are capable of different modes, ranging from AX-25, packet, APRS, FM, and even single sideband. They're free of charge for any licensed amateur radio operator to use. As of this time, there are over 18 fully functional amateur radio satellites in orbit. Contributions and technology from the ham community have helped with the advancement of these satellites. One particular contribution is the launch of the first satellite voice transponder on Oscar III. Another is digital store and forward messaging transponder techniques. The amateur radio satellite community is active in building satellites and in finding launch opportunities to get them in orbit. Lists of functioning satellites need to be updated often since new satellites are launched and older ones fail. The current operating satellite information is posted by AMSAT. You can find more information on their website. When I just had my technician, I used to really be into trying to listen to those things, and that and the Mir space station.
Oh, yeah.
Fun stuff.
Copy them on packet, and you could see the battery voltage and all those good things.
The telemetry. Yeah, that was really cool.
Yeah. Well, speaking of that, I've got a couple of satellite things to mention here. First, I want you to listen to this and tell me what you think this is. If you had to guess, what would you say that was?
I don't know, but my dog thinks it's time for her to come in here and get a treat.
It sounds just like a cricket, doesn't it?
Uh-huh.
That is Oscar 2. That is what it sounded like. That was a long time ago. The first amateur satellite was named Oscar 1. It was launched on December 12, 1961, barely 4 years after the launch of the world's first satellite, Sputnik. The beginning of this project was very humble. The satellite had to be built in a very specific shape and weight, so it could be used in place of one of the weights necessary for balancing the payload in the rocket stage. Oscar 1 was the first satellite to be ejected as a secondary payload and to subsequently enter a separate orbit. It carried no onboard propulsion, and its orbit decayed quickly. Despite orbiting for only 22 days, Oscar 1 was an immediate success. Over 570 amateur radio operators in 28 countries forwarded their observations to Project Oscar. Well, I guess we should get on into the questions for tonight's episode. And
you got the buzzer warmed up?
As a matter of fact, I do have the buzzer warmed up.
Awesome. Because there could be some buzzer action tonight. You just never know.
We may need it.
What is the direction of an ascending path for an amateur satellite? A, from west to east.
B, from east to west.
C, from south to north.
Or D, from north to south. What is the direction of an ascending path for an amateur satellite? Let me think about that just a second. If it was descending, that means it would be going down. So ascending would be going up. And since north is up, I guess it depends on where you are, but it seems to me like that's the top of the world. So I'm going to say that would be ascending. So let's see. I'm going to say it is C, from south to north. They're kind of guessing different answers in the chat room there, which is, well, let's see. I don't know if I got it or not. Anyway, there we go. From south to north.
That's one that made sense to me. Oh, well, right through the wall. Did you see that?
Yeah, I did. Okay, well, I have one for you then.
All right, make it an easy one.
Yeah, okay. I picked out one especially for you here to be easy. Which of the following occurs when a satellite is using an inverting linear transponder? A, Doppler shift is reduced because the uplink and downlink shifts are in opposite directions.
B, signal position in the band is reversed.
C, upper sideband on the uplink becomes lower sideband on the downlink and vice versa.
Or D, all of these choices are correct. Ooh, this is going to be a tough one. Inverting linear transponder. I'm just guessing, but I'm thinking that's something to do with the Doppler shift, because I know that's an issue with the satellite stuff, with the frequency drifting. Doppler shift is reduced because the uplink and downlink shifts are in opposite directions. That seems plausible. Signal position in the band is reversed. I think that means the same thing. Doppler shift. I think that means the same thing as A. I think. C, upper sideband on the uplink becomes lower sideband on the downlink, and vice versa. Sideband. It's kind of, you got to think about this one. This is tough. You're right. You really need to study these.
Yeah.
So far, I think A and B seem like plausible. If what a linear transponder is what I'm thinking it is, I'm pretty sure it's got something to do with the Doppler shift or the frequency shifting. I'm going to guess. I think it's D. A and B seem plausible to me, and by process of elimination, C would have to be 2, because I think both of the A and B's are essentially saying kind of the same thing in a way.
Okay, that seems to be the most popular answer in the chat room, not the only one. Well, let's see. And you are correct, sir.
Well, I got pure luck. That was pure luck right there.
Well, be careful not to punch a hole in the wall.
How is the signal inverted by an inverting linear transponder? Oh, how timely for that one. A, the signal is detected and remodulated on the reverse sideband.
B, the signal is passed through a nonlinear filter.
C, the signal is reduced to I and Q components, and the Q component is filtered out.
Or D, the signal is passed through a mixer, and the difference, rather than the sum, is transmitted. Gee, that's there's a lot of possibilities there, and there's not two that are the same.
No, and there's no all these are correct either.
Now, let's see. Hey, well, first, how is the signal inverted by an inverting linear transponder? You might think, A, the signal is detected and remodulated on the reverse sideband, and that would get you on the opposite sideband. It would be inverting. B, the signal is passed through a nonlinear filter. Now, just because it's inverting linear, that does not mean nonlinear. It's still linear. C, the signal is reduced to I and Q components, and the Q component is filtered out. I don't think that's it. D, the signal is passed through a mixer, and the difference rather than the sum is transmitted. Let me give a couple of clues here. We've already figured out that inverting meant that it was flipping the signal around, so whatever was on upper sideband was on lower sideband, and or vice versa. And so that would be...
A seems possible.
That would be inverting. Now, that's assuming it was a sideband signal, which, may not necessarily be, but could be. And a linear transponder. Well, a linear, like a linear amplifier, means whatever you put in, you're going to get out pretty much an identical signal. There might be a little distortion in a linear amplifier, but not much. Typically, they have to be pretty clean. So linear means, it's going to be a copy of what you put in. And a transponder, well, that's what's up there on the satellite that's turning the signal around and sending it back to us. You might think detected and remodulated on the reverse sideband, but that's not the answer. And, as I said a minute ago, nonlinear filter, that wouldn't be it. And stripping out the Q component, filtering it out, that's not it. It is D, the signal passes through a mixer, and the difference rather than the sum is transmitted. And a mixer is what is used in a super heterodyne radio. So, and in that case, the signal's coming in on one frequency, and we're shifting it down to another frequency to work with it because it's a little simpler. But we don't demodulate it. It's still the same signal. It's just been shifted in frequencies. So that's the theory there. It's the same sort of as a super heterodyne radio. And whenever you mix two signals together, like your original signal, and you mix it with another frequency, inside that mixer, coming out, you're going to have the original signals that you put in, plus you're going to have the sum of the two added together, and the difference of of the two subtracted from each other.
Mm-hmm.
And you just pass on through whichever one you want there. And I'd say that's what they're doing. It's D. In the chat room, they were kind of, most of them who got it right said that. The ones who didn't, though, they guessed something else.
Yep.
Direct translation, whatever's coming in is what's going out. Except upside down if it's inverting.
Upside down and backwards.
Yep. So I got one for you.
Okay. Hope it's not like that last one.
Oh, it's different. What is meant by the term mode as applies to an amateur radio satellite? Is it A, whether the signal is in a low Earth or geostationary orbit?
B, the satellite's uplink and downlink frequency bands.
C, the satellite's orientation with respect to the Earth.
Or D, whether the satellite is in a polar or equatorial orbit. Interesting.
And
the term mode. Mode. When I think of mode, I'm thinking about something to do with the radio gear itself, not the mode that the satellite's running in. 3 of those have to do with the way the satellite's in orbit. I think it's going to be B, the bands. Actually, yeah, it is going to be the bands. B, my answer is B. That's my final answer.
Well, that's what everybody's saying in the chat room. I think you're probably right, and you are.
What do the letters in the satellite's mode designators specify? A, power limits for uplink and downlink transmissions.
B, the location of the ground control station.
C, the polarization of uplink and downlink signals.
Or D, the uplink and downlink frequency ranges. What do the letters in a satellite's mode designator specify? Well, seems like I'm having a little bit of deja vu right here.
Yeah.
Seems to me that
It seems like we touched base on that just so it hasn't been all that long back.
Yep. No, I don't think it has, and fortunately, I don't think short-term memory is failing me this time. What do the letters of satellite's mode designator specify? Well, I don't think it's the power limit. The location of the ground control station. I don't think so. The polarization of uplink and downlink signals. You might think that could be it, potentially. The other two don't make sense. D, the uplink and downlink frequency ranges. I'm going to go with D. Chat room saying D.
Yeah,
And
I think you're right.
yeah, I think I am. The H band, 15 meters. A would be 10 meters. V would be what you'd think, 2 meters. U, 70 centimeters. The L band, we've heard that before, 23 centimeters. The S band's 13, S2 is 9, C is 5 centimeters. That's 5 gigahertz. We've heard of, C-band satellites. X We've heard of
3
X band.
centimeters.
Yeah, 10 gigahertz. K, 1.2 centimeters. And R is 6 millimeters.
Wow. 47 gigs.
That's up there.
Wow.
Now, I'll be honest, I had to kind of, I couldn't remember them all. And short-term memory is not helping me this time. I can't remember them now. We just looked at them. Some of them I would get right, but so there's the bands. Fortunately, I don't think that's going to come up any further on the band, but we'll on the questions here, but we'll see in just a moment. Well, I got one more question here for you before we move on.
Okay.
What are Keplerian elements? A, parameters that define the orbit of a satellite.
B, phase reversing elements in a Yagi antenna.
C, high emission heater filaments used in magnetron tubes.
Or D, encrypting codes used for spread spectrum modulation. And this one, I actually know what these are because I've actually sat down and typed in some of these before, back in the early days. Remember the old TrackSat program for DOS that used to do the satellite tracking?
Yep.
You had to go to the BBSs and get the elements in the program. Like I had to type some of them in.
Yeah.
First. And I know that's going to be parameters that define the orbit of a satellite. So, like on my program here that's running in the back, we've got the space station being tracked there. There are Keplerian elements in that right now that it's using to calculate that path of that satellite or that space station.
I'll agree with you.
Huh?
I said I'll agree with you. Everyone in the chat room does too. And I
got them fooled.
There you go. No buzzer action yet, but the night's still young.
The night's still young.
Yep.
We haven't burned anything down yet either.
No, we're working on it. Why don't we take a break?
I hear a siren out there.
Fire truck?
Oh no, it's kind of off in the distance.
Yeah. Why don't we take a break, let everyone go to the snack bar or wherever it is they might need to go before we continue on. And we'll be back in just a moment with more. Get out and be active with ICOM's new IC705 and its optional multifunction backpack. Now shipping. The IC705 is your perfect QRP companion as you have base station features and functionality at the tips of your fingers and a portable package covering HF 6 meters, 2 meters, and 70 centimeters. This compact rig weighs in at 1 kilo or just over 2 pounds, with RF direct sampling for most of the HF band and IF sampling for frequencies above 25 megahertz. 5-watt battery operation with BP272 or 10 watts with a 13.8 volt DC supply. Modes include single sideband, CW, AM, FM, as well as full D-Star functions, a large 4.3-inch color touchscreen, and live band scope with waterfall, micro USB connector, Bluetooth, and wireless LAN, integrated GPS with antenna and GPS logger, micro SD card slot for data storage. It comes standard with the HM243 speaker microphone, and it supports QRP and QRP-P operations. The perfect accessory for the IC705 is the LC192 optional backpack with a special compartment for your IC705 and room for accessories for soda activations or just a day in the park. Visit ICOMAmerica.com/amateur for more information about this and all the great ICOM radios. Speaking of the IC705, Tommy, that's seeming more and more familiar to me these days. What about you?
Yeah, it does. It looks like you must have put a light bulb in your box back there because it looks like that fake one you got on your desk is kind of glowing.
It does, doesn't it?
Do you put a light bulb in the box?
No, I got two of them. Turns out my scale model replica wasn't exactly scale model. So,
go figure.
Somebody's going to win a, sure enough, real radio here, not a cardboard box.
Yeah, second prize winner get the cardboard one?
Could be. I'm not going to get to keep this one. This is going to be the one we're giving away right here, but I know somebody who just acquired one of these, and I haven't really had much report from him yet.
I should have brought it over here. It's sitting on my workbench over there where I've been kind of doing. I've been putting some, or about to put some Anderson power poles on the power cord to hook up to my battery. I'm pretty excited about it. I hope the weather turns a little bit better so I can get out this weekend with it.
Well, that'd be fun. I think it is going to turn a little better this weekend. So, yeah, I want to hear about it. I have only had a chance to play with this one just a few minutes here because it just came a couple of days ago.
Right. And I checked in on D-Star on the Soundcheck net on Tuesday.
I checked.
By the way, those of you that are out there watching, you should join us on Tuesday nights for the Soundcheck net. It's a lot of fun. We got a lot of modes you can get in on D-Star, DMR, Fusion, All-Star, Echolink, P25. What is it? It's NXDN, Ham Shack Hotline. I think that's most of them. But anyway, watch for the postings in the social media and come join us. It's a good time.
Yeah, real good time. Okay.
Hey, you like the way I throw the little shameless plug in there for the net?
I do. I just noticed. Oops, let me do something here. That was a good plug there. We had a great time this week with Amanda and Jeff calling it.
Yeah, she beat us. You had the record, then I had it the next week, and then she beat both of us.
Yep. I promised earlier that we would be playing a game of strip poker here tonight to see who wins your shirt.
Right off my back.
Right off your back. If somebody wanted to win your shirt, how would they go about doing it?
Well, they want to win this shirt, and it's a really good shirt too, so you probably want to get in line. The back looks as good as the front does, so send in an email to hamcollege@AmateurLogic.TV. You don't have to be licensed. All you need is a name and an email address.
Yep.
If you want to put a little note in there too, that's fine, but it's not required. It's nice to read them though when we get them, but it's that simple. Your email addresses are not harvested, they're not given to anybody else, they're not even kept by us. The only one that goes anywhere is the winner. It goes to ICOM, and then they don't keep it after that. So it's safe. We're not trying to get your email addresses for anything. If you don't happen to win this time, be sure you send your entry in again next month because they don't carry over. So you'll need to re-enter each month until you win.
Well, I did the random drawing just before the show tonight, and we have a lucky winner here. He says, "Hi, George." Actually, he says, "Hi, Gorge and Tommy." Little misspelling there. "Please add my name to the next drawing for the ICOM hat and shirt. Thanks. Billy Steen, W5KOZ."
Okay. Well, congratulations, Billy. And I'll go ahead and take this off and put it in the box right now.
Okay.
Actually, I better wait till after the show's over.
He may just want to swing by and pick it up. This is, and it's just a coincidence because it had nothing to do with him winning. He just happened to have the lucky entry this time around that got drawn. I know Billy Steen. He lives about 75 miles from here. He's in Kosciuszko. And
I figured he might have been with the call sign.
I went to school with him, and we also both worked Our first radio station jobs were at the same radio station. He is now W5KOZ. The radio station is WKOZ. And you know, I hadn't seen Billy for years. And I ran across him at a Society of Broadcast Engineers meeting. I think it was last year. He came down here for one of those. So you're going to look good in Tommy's shirt there. You may have to pry it off of him. Actually,
yeah, you may want to wash it. It's kind of warm in this room in here.
We'll actually have ICOM send you a new one, and they'll throw some other stuff in the box too, like a cap, and I don't know, whatever Jesse's feeling like sending that day.
Yeah, but congratulations.
Yeah.
So if you didn't win, be sure to go ahead and resend your entry for next month's drawing.
Yep. Ham College at AmateurLogic.TV. Let's see, the last question, I think I asked you that one, so it's only fair that I ask you this one too. No?
I don't think so. Don't work like that.
Okay.
Which of the following types of signals can be relayed through a linear transponder? A, FM and CW.
B, SSB and SSTV.
C, PSK and packet.
Or D, all of these choices are correct. And I'm afraid I may have given away the answer when I was doing some splaining earlier.
Yep.
Which of the following types of signals can be relayed through a linear transponder? Well, as I said, you know, linear is whatever's coming in is what's going out. You don't care if it's FM or CW or sideband or SSTV or PSK or packet. All of those will pass through a linear transponder. So I'm going to say it's D. All these choices are correct, and everybody in the chat room seems to agree with me on that one. Here we go. So,
congratulations.
I think we need to make this a little bit tougher. These have been too easy so far.
That hasn't been too bad, really. There was a couple at the beginning I had to guess pretty hard on.
Yeah. But your guesser is working pretty good tonight.
Go figure.
Why should effective radiated power to a satellite that uses a linear transponder be limited? A, to prevent creating errors in the satellite telemetry.
B, to avoid reducing the downlink power to all other users.
C, to prevent the satellite from emitting out-of-band signals.
Or D, to avoid interfering with terrestrial QSOs. Prevent creating errors in the satellite telemetry. To avoid reducing the downlink power to all other users. That sounds plausible because sometimes there's more than one service on there. Prevent the satellite from emitting out-of-band signals. To avoid interfering with terrestrial QSOs. So I'm thinking A or B, but I'm thinking B. Avoid reducing the downlink power to all other users. So if there's more than one, if that's a shared system, then you don't want to like starve one, give all the power to the other ones. I think I'm going to go with B.
Okay.
Just a hunch. I'm not positive though. But I think it's B.
They're a little mixed in the chat room.
We mostly got B's in there.
I believe that, well, I'm going to agree with you.
Oh, I'm glad this one's got your name all over because I don't remember that chart.
Yeah, I don't either.
What do the terms L-band and S-band specify when regarding satellite communications? A, the 23 centimeter and the 13 centimeter bands.
B, the 2 meter and 70 centimeter band.
C, FM and digital store and forward systems.
Or D, which sideband to use. Ooh. It's not like I know the right answer, but I know which ones are wrong here. Let's see. What do the terms...
Sometimes that's good enough.
Yeah. Yep. What do the terms L-band and S-band specify regarding satellite communications? Well, we know it's not which sideband to use because we've already said the band specified, or the L-band, S-band, that was specifying frequency bands. So it's nothing really to do with C, FM and digital store and forward systems. And I do remember B, there are 2 meter and 70 centimeter bands. Well, I know that's VHF and UHF, so it can't be that. And I know L-band and S-band are higher frequency bands. So that could only be the 23 centimeter and 13 centimeter bands out of our possible answers there. So that's my logic on it. Everybody else is saying A.
If you're not familiar with that stuff already, you really want to study these very good, because you just do.
What type of satellite appears to stay in one position in the sky? Is it A, HEO,
B, geostationary,
C, geomagnetic,
or D, LEO? And this one I just know, and probably most people know. If you've ever had satellite television, you've probably read it when you were setting your dish up and stuff. But this one's just going to be B, geostationary. It stays in the same point in the sky all the time.
I'm going to agree with you, as does everyone in the chat room. They're doing pretty good. Apparently, there are some astronauts in the chat room tonight, because they're knowing just about all the answers.
Yeah, they all got their heads in the clouds.
But I would say, yeah, out of all the questions that we're going to cover here tonight, I think this is the one that just about everybody would get, because...
Yeah, everybody's had at least most everybody's had at least a little bit of exposure to that term.
Yep. Okay, on to the next one.
What type of antenna can be used to minimize the effects of spin modulation and Faraday rotation? A linearly polarized antenna.
B, a circularly polarized antenna.
C, an isotropic antenna.
Or D, a log periodic dipole array. What type of antenna can be used to minimize the effects of spin modulation and Faraday rotation? That means that the satellite is going to be spinning as it goes through its orbit. The spin keeps changing whether you're going horizontal or vertical. It's constantly changing. So a linearly polarized antenna, you wouldn't think that's it, because that's going to lock you down on a particular polarization. And if you know that the polarization is changing, D, a log periodic dipole array. No. A dipole, that's either going to be horizontal or vertical as a log periodic as well. An isotropic antenna. No, I think that has a fixed polarization. It's a circularly polarized antenna. And that may, if you're not familiar with that term, that may sound strange, but that's it. It's B. And
I got one right over there.
Yep.
On my drone.
And they all got that one right in the chat room too. What is the purpose of digital store and forward functions on an amateur radio satellite? Is it A, to upload operational software for the transponder?
B, to delay download of telemetry between satellites.
C, to store digital messages in the satellite for later download by other stations?
Or D, to relay messages between satellites. Store and forward. I just so happen to know what this one is. This one's going store and forward is basically storing messages almost like an answering machine. So it's going to be C, to store digital messages in the satellite for later download by other stations. And I don't know how to reason that out other than just that's what the answer is.
Okay. Well, everybody else in the chat room is saying that's the answer. So I'm
Could
pretty
be
sure.
something. Could be onto something here.
Yeah, I'm pretty sure you're right. And you are. Yeah, there's even a repeater type, store and forward repeater. It's a cheap way to build a repeater.
Which of the following techniques is normally used by low Earth orbiting digital satellites to relay messages around the world? A, digipeating.
B, store and forward.
C, multi-satellite relaying.
Or D, node hopping. Which of the following techniques is normally used by low Earth orbiting digital satellites to relay messages around the world? Digipeating. Well, that's basically whatever comes in is being transmitted right back out digitally. So that is, I would almost think that's store forward, but it's, I don't guess they're classifying it as that because, you know, it's immediate. As soon as it's received, it's sent on out. B, store and forward. Seems to me like I've heard of that before recently.
Yeah, fairly recently.
Yeah.
It's almost like it was just...
And me and everyone
So clear.
else in the chat room thinks that's it. C, multi-satellite relaying. You know, I guess that would be possible to relay from one satellite to the next all the way around the globe, but it's going to take a lot more frequencies and a lot more power, and it's not the way that it's not the normal technique that we would use with low Earth orbiting satellites. So that's not it. And node hopping, I'm not even sure exactly what that is, but I don't think that's it. Store and forward, and you all knew that. Well, that is all of our questions tonight. Now
What?
you
So
two,
soon?
you two are qualified to be a ham in space.
Hams in space.
I can't believe we
I
didn't.
just hear that every time I... You
Yeah.
know what I'm talking about?
Oh, yeah. I can't believe that we got them all correct tonight. And then the chat room did really well with it, too. So,
It was purely an accident. Believe me.
okay. I'll take your word for it. Yeah, I kind of believe you, too. We're going to be back in just a moment because we're going to tell you about how you could win even this very radio, as a matter of fact, right here. So don't go away. We'll be right back. Are you new to the ham world or an existing amateur operator who wants to take your license to the next level? Study for your radio license exam at hamstudy.org. Hamstudy.org is a free online learning tool powered by ICOM. It was created by Richard Bateman, KD7BBC, Michael Stufflebeam, KV9G, and Rich Porter, KK6GKE, and it uses a modern web design to enhance the experience of studying for your technician, general, and amateur extra exams. Since 2013, hamstudy.org has helped new and existing hams to familiarize themselves with the question pools, use stats-based flashcards to focus on material they need to learn, and take practice exams to gauge progress. Visit hamstudy.org on your desktop computer or mobile device. Register for a free account at hamstudy.org to access personalized study history and other site features. Prepare for an exam in an intuitive and comprehensive manner. Check out hamstudy.org, powered by ICOM, for free learning tools. Good luck on your next exam. Talk about giving away a radio.
Let's give away a radio.
Okay, why don't we?
We got the twin to that one.
Oh, you got one right there, don't you? Well, let's give away 2 radios.
No, let's don't.
Okay. Well, we'll give away this one I've got over here then. It's AmateurLogic's 15th anniversary contest. That's right, we'll be celebrating 15 years on the air next month. We've got some great prizes lined up here. The main prize is something that you're all familiar with by now because we've been talking about it for a good while. And you know, with the pandemic, production got slowed up and all, but these are out actually shipping. You just saw 2 of them in the wild here. There's one right there. And I gotta say, Tommy, now that I've held one in my hand
Over here somewhere.
and played with it a little bit. I mean, we had seen, the one that Ray had before. That was a demo model. It wasn't an official U.S. version, but now that I've actually played with it some myself, it's got me wanting one.
Yeah. It's pretty sweet. The weather, I think you said the weather's supposed to be better this weekend. I can't wait to take mine out and play around with it.
That's going to be a lot of fun. Boy, and it's just like having a 7300 right there in the palm of your hand that'll run off battery power, except it's also got VHF, UHF, and D-Star in it.
Yeah. I probably got the only 7300 with a rubber duck on it.
You probably do. It's a new hybrid radio that's got base station radio performance and functions packed into a compact and lightweight portable size, perfect for SOTA, POTA, or some other on-air location. 10 watts output with a 3.8 volt external DC power, and it comes with a cable for that, or 5 watts with a BP 272 lithium-ion battery pack, and it comes with one of those. Just so happens, though, that's the same battery that a number of current model ICOM handy-talkies take, and that's what's on my ID 51. This radio's got HF 6 meters, 2 meters, and 440. It does D-Star, DV, SSB, CW, AM, and FM modes. It has that ICOM RF direct sampling system, so it's not just a conventional radio and then they convert it to a digital signal. It actually does direct sampling of the signal straight in without going through a lot of IF stages. A high-speed, high-resolution, real-time spectrum scope and waterfall display are incorporated as well in this compact design for the first time in this class of radio. It's got D-Star functions built in. It's got GPS functions built in as well. It actually has a GPS in it. And this one right here, right now, it is flashing because we're in a metal building and it can't see the bird. But if you took it outside, it would lock right up. Also, there's an optional backpack that is available. It's the LC-192. Unfortunately, those are currently back ordered, so we won't have one in time to give away on the contest, but it's a perfect accessory to go with that rig because the radio fits right there in the top of the backpack, and it actually screws in with a 1/4-20 mount. That's the same threads as was used on a tripod and many other type of mounts, so once you screw it into that backpack, the radio will not fall out. And there's a lot of room to put other stuff in there as well. Large 4.3-inch color touchscreen, built-in Bluetooth and wireless LAN, and there's a micro SD card slot, and it comes with this right here. It is the H243 programmable speaker microphone. And that's a good feeling little microphone too. It's heavy. And very good rubber cord on it as well. I was impressed with that. Just quality stuff, you know. When you look at this rig, you're going to know it's not a toy. It's a real thing. So, what else might you want to go with that, Dean?
Well, if you got a radio, you're really going to need an antenna, aren't you?
I think.
So how about an MFJ 2289 big ear HF antenna? It's a portable, easy to set up, and easy to tune antenna. It's a great pair with the ICOM IC705. Good coverage antenna as well. The MFJ 2289 big ear can be tuned down to exceptionally low SWRs on any frequency between 7 and 55 megahertz. So that's a good bit of range right there. 17-foot stainless steel whips, so you get 34 feet of antenna in the air. That's going to give you some pretty good perception. They're going to have some RG8X coax from MFJ as well. In addition to the antenna, it also comes with the tripod, the mast, and the carry bag that you can see there on your screen. So that's going to make it pretty easy to lug around through the park or up the mountain or wherever you're going to go set up. If you happen to be someplace that has some AC, you're going to want a power supply to plug it in to save your battery for when you're out portable with it. So how about the MFJ 4115 power supply? It's compact, great for traveling. It only weighs 1.5 pounds. It'll fit nicely into that backpack. Output 13.8 volts at 15 amps continuous. And that's enough to power most VHF, UHF, or QRP radios.
You might want a headset. So you'd probably want a Heil BM17 headset. Seems like a good make to me. It's a medium weight headset designed for emergency communications. It's also perfect for portable and on-the-go operations. It comes in single side and dual side models. The speakers used in the BM17 are very sensitive and don't require much AF drive from the transceiver, so you're not going to be eating up your batteries, cranking the volume up. And there's a Heil AD1 adapter available for most popular rigs. And we got one more thing.
A set of Forrest Mims engineered mini notebooks. Actually, I've got a set of those little mini notebooks.
And where did you get those?
Well, I got mine from Radio Shack, but since Radio Shack is no more, you can get them from Master Publishing.
Yep.
Or you could win them if you're the lucky person.
Yep. W5YI.org is where you can order these. You know, these are like the notebooks that Radio Shack did sell back in the day, except these are the latest editions right here, and also the latest edition of Getting Started in Electronics by Forrest Mims. You know, Forrest does really great work. All the drawing, schematics, and writing in these books was done by hand. Just really, really detailed work in there. Very easy to follow. I have built a lot of these circuits in the past and put different ones together as building blocks to make a project that I wanted in. Mm-hmm. It actually works and saved me a lot of time scratching my head and trying to figure it out. Forrest has put just the amount of information in here you need to build them, experiment with them, and without overloading you with too many details. I mean, you know, if you're going to work with, say, a 555 timer, you might not actually want to read through a 15-page data sheet for that chip. With these books, you can just cut right to the chase and find out how to start using it right away. It's a great way to get started building electronics and experimenting, so I highly recommend it. W5YI.org. Thanks to them. And Master Publishing, that is also Gordo's publisher, the guy who publishes the Gordon West Amateur Study Guides. So we appreciate all that. So what if you wanted to win this stuff, Tommy? I know there's got to be somewhere that you could go and find the details on this contest.
you can go to AmateurLogic.TV /contest and get all the details from there. But how about if I tell them how to save a little time and go ahead and tell them how to enter? All you got to do is send an email to contest2020@AmateurLogic.TV. Be sure to put only your call sign in the subject line. Include your name, call sign, class of license, and your address in the email message. Submissions must be made between Friday, August the 14th and Monday, October the 12th. So that's coming up pretty fast.
What would you have to do to be qualified? Well, you've got to be a licensed U.S. or Canadian amateur radio operator with a U.S. or Canadian shipping address. There's only one entry per contestant allowed. Sending more than one entry is going to disqualify you from winning. The winner is responsible if there are any taxes incurred. The winner agrees to use his or her call sign and name in promotional and news-related items for the contest, and contestants must not be an employee or affiliate of AmateurLogic, ICOM, MFJ Enterprises, Heil Sound, or Master Publishing.
The contest winner is going to be selected by a random number from the entries that we receive. The winner will be announced on October the 16th episode of AmateurLogic.TV. If it's determined that the winning entry does not meet the qualifications or requirements, then the other winner will be chosen by the same method. And like I said, the contest rules and information will be posted at AmateurLogic.TV /contest.
Well, we're giving away the shirt off of Tommy's back, and Billy is going to enjoy that. Billy Steen, our winner tonight. But you might need a shirt yourself to, I don't know, go to a Hamfest if there are ever any more of those, or a club meeting.
They'll be back.
Or just to look good when you're out, sporting the wife around in your Granada. Where could you get one?
So I can hook you up with that. All you've got to do is go to AmateurLogic.spreadshirt.com. And there's Ham College and AmateurLogic swag there in the store. Go check it out. We've got cups, mugs, backpacks, golf shirts, caps, everything. You just name it. There's all kinds of stuff in there, more than we've ever had. So anyway, go check it out. You're bound to find something you like in there.
Yep. And also, don't forget to send an email to us, hamcollege@AmateurLogic.TV, to see who wins Tommy's shirt next month.
Yeah. It's going to be getting kind of cold in here pretty soon.
Yeah, it is. You're going to want that
Run
shirt.
out of shirts.
Well, during the month, you can catch up with us socially. We are social distancing, but we found some good tools to do that with. Facebook.com/groups/HamCollege.
We're on Twitter @HamCollege.
Or groups.io/g/AmateurLogic. And you can find us posting in those areas and generally having a good time and finding out what everybody's talking about. We don't spam you really on the groups.io. You'll only receive an email mostly when there's just, when we got a live stream coming up or we've just released an episode.
Yeah, or a reminder for the net on Tuesday.
Yep.
That's most of it. So if you don't want a lot of stuff, you can also, if you sign up on the Groups.io account, when you do, you can set to give you a digest of one email a day. So if you don't want to get random emails throughout the day, which there aren't that many, which one we set it up, but you can make sure that you only get the one if you set that option.
Yep. Well, I think that's going to do it for tonight. It's been a fun show. I'm surprised that we got through those questions unscathed.
Well, as always, next week.
Or next month. Yeah, there is.
That too. I could get scathed next week. You just never can tell nowadays.
Well, that's true. You'd never see it coming. It is 2020.
Yep.
Well, we'll see you next month at the end of the month for the next Ham College, or in the middle of the month. It's actually, I believe we're saying, when is it? October 16th, we'll be shooting our 15th anniversary episode of Amateur Logic. And You need to be there to see who's going to win this package and what kind of fun we might have.
Yep. And if you haven't made your entry, go ahead and get it in. It's not too late.
Yep. True.
Go ahead and enter for the shirt, the ICOM swag too, while you're at your computer there and sending emails.
That's right. And let me see, the October 12th, that's the last date that you can enter in the radio drawing here. So good luck to someone. Someone's going to win it. Well, I guess that does it for me. We will see you in class next month.
Yep. Don't be tardy. There'll be a pop quiz.
7-3.
7-3.
He is now W5KOZ, the radio station. That was interesting. The radio station is WKOZ. That's a fan hitting the floor over there. So it's the floor that hit the fan. It wasn't anything else.
Be sure to go ahead and get your entry. Resend your entry.
You may want a headset to go with that. I mean, it comes with a really nice speakerphone here. Speakerphone, that's not the right term.